A very warm and very lovely good morning to everyone. My name is Gaurav Jain. Today, I will explain a third part of convolution neural network series. In first two videos, I explained you the basics of convolution neural networks and layers in convolution neural networks. Today, I will explain you the architecture of convolution neural networks. Like there are different architectures which is evolved with time. Like earlier in 90s, the first architecture was introduced was LeNet, and after that AlexNet was introduced, then after that VGGNet, then ResNet, then UNet. You will understand all these architecture in this video. I am assuring you that you will get a very deep understanding of these architectures, how these architecture works, what is the basics structure, and what is the functioning going on in these architectures, how what is the need of these architecture, and what is the need of different tasks, what is the need of these architectures for different tasks, like that. So moving ahead to our new topic of LeNet architecture, LeNet 5. So what it look like? It look like as a combination of convolution, average pooling layers, and fully connected layer. So you will find I already mentioned that the convolution neural network contain all these three layers. Whatever type of architecture it is, these three layers will definitely present. But in case of UNet, there is one extra layer is present, which is transpose convolution also, and ResNet layer also there. So you will find all these concepts later on. So first of all, let understand the LeNet architecture. So in this architecture, we had provided an image of 7. This image was these images were processed by the filter size of 5 by 5 and standard of 1, and then we get an output size of image is 28 by 28 and number of filters are 6 we had taken. Then we do the average pooling. In average pooling, we kept the size of filter is 2 by 2 and the stride we do the 2, and then we get a size of 5 by 5. We get a size of 14 by 14 into 6. We use the 6 number of filters in average pooling. That is why we are getting 14 by 14 into 6. Then we moved to, we apply the we apply the convolution neural layer again, and keep the filter size 5 by 5 and take the stride of 1 and get a output size image 10 by 10 into 16. You may wonder that how we are getting 10 by 10 size in output. If you remember that we used a formula to get output size of image, which was the formula was n minus f plus 1, sorry, n minus f plus 2p divided by s plus 1. So this is a generalized formula for getting any output size of any image. So putting all these values in that formula, we will get 10 by 10. So I'm showing you that how I get. So 14 minus 5, 9 divided by 1 plus 1, 10. So this is how you are getting the output size 10 by 10, and 16 is the number of filters used in convolution layer. So after that, we apply average pooling layer. In this layer, we keep the size of filter 2 and stride size of 2 and take the stride of 2. So we getting the 5 by 5 into 16 output image, and then we flatten that image matrix in the form of column vector, and that column vector was connected to fully connected layer which has at 120 neuron, and then in this fully connected layer 120 neuron again connected with the 84 neurons of another hidden layer, and then it is connected to softmax or sigmoid as your choice based on your dataset. So this is how LeNet architecture look like. It has a 60k parameters, and convolution pooling and fully connected. These are the internal part of this architecture. And sigmoid 10H or ReLU. Yeah, I forgot to tell you that there are different types of activation function. We can use anyone, but it should be matched with our dataset qualities, because if we implement any activation function, the results may vary and may get worse. We get worse result by using a different activation function. So keep in mind that if we are getting the values between 0 to 1 or always positive, then we should use the relocation function, because relocation function, what it does, it keep the negative values into 0 and the positive values directly give the similar output. So it has a range minus, if input input data is between the infinity to 0, then output will be 0, and if input is between 0 to infinity, then output will be x. So this is how relocation function works. And advanced version, or another leaky relocation function, it is also similar to relocation function, but what happen in this function is that in leaky relocation function, we have a slightly negative output also, because earlier we in relocation function, we if we get any negative input, we directly put into 0. But in case of leaky relu, we only we in case of leaky relu, we also get negative output for negative values, but it is very small as compared to for positive output in leaky relu activation function. So this is how leaky relu activation function works. Let's move ahead, and you can see that NH and W is decreases and C increases. You can see that in this layer, NH, what is NH denoting here? NH denoting the size, and NW is denoting the width, size, height of image, width of image, and NC is the number of, what is NC? Number of, you can say it is a basically number of filters. So you can see that when we proceed with our layers, our NH and W decreases, but filter size increases. Like you can see in first layer we taken 6 filters, then 6 filters, then 16 filters, then 16 filters. So you can see that we decreases the size of image and increases the number of filters. Why? Because we want to learn maximum amount of features. That is why we are increasing the filter. So that we get very good results. Now moving ahead to AlexNet. AlexNet also advanced version of LeNet. It is invented after many years, not many years. So in this AlexNet, it is input size image representation in the form of 226, 227 by 227 into 3. 3 is representing red, green, blue channels. So we apply first convolution neural layer. In that layer, we keep a size of filter 11 by 11 and take a stride of 4, so that we can get output of 55 by 55 into 96. 96, it is a number of filters, so you can imagine that how much amount of filter we had taken. So, and basically keep remember one thumb rule is that the number of filters will be in the form of power of 2n mostly. It is not a compulsory, you can take based on your imagination also, but it should be divided by 2. The remainder of division of 2 should be 0. So after convolution layer, we apply max pooling layer. In max pooling layer, we keep a size of filter 3 by 3 and spread equals to 2. Then we get size of 20 by 27 by 27. Similarly, this is how it works. So in this architecture, we get 60 million parameters. You can imagine that in LeNet, we only get 60K parameters, but in AlexNet, we get 60 million parameters, which is good for capturing the features of images and producing better results than LeNet. Similarly to LeNet, but much bigger, relocation function we used multiple GPUs required for training, because just because of if we increase the parameters, definitely there will be increase in computational cost and time. That is why we require multiple GPU. Local response normalization, I will tell you later. Right, for now, it is not a very big deal for you, and I'm also not getting what is this. So you can search on Google also and write in comment box. Right. And after that, VGG16. In this architecture, it is also advanced version of previous architecture, which is AlexNet. So VGG similarly there is also there are always three layers makes pooling layer, convolution layer, fully connected layer. It is a combination. But what is happening in in this architecture? We simply added more convolution and pooling layers and fully connected layers and increasing the parameter size. Earlier we had only 60K parameters, then we moved to 60 million parameters, then we moved to 138 million parameters. This is how uh, the parameter size increases so that computational time also increases. So there is no difference in processing. Main difference is we add more layers. That is why this architecture name was obtained as a VGG16. Now residual networks, ResNets. These are also called ResNet. These are the very genteel networks. They what they do, they they simply skip the layers in between the neural architecture and connect the one layer to another any layer of that architecture. So this is how what is AL. AL is denoting the output of radio activation layer, and this after from that output it is input for linear layer. Layer can be convolution or artificial fully connected layer, because in we will do only linear sum in that wx plus b. That is why we are calling this linear processing. Then we goes to table activation function, and then again linear layer. Then again we do the sum of previous input layer we are getting from ALth layer, and the we are getting output from AL plus 1 layer. We do the sum and pass it into relocation function and get AL plus 2 layer. So this is how skip connection of ResNet works. Why the need of ResNet? Because if we simply increases the number of hidden layers, then our training error will increase slightly in reality. But in theoretically, it should be low. It should be low as we increase the number of layers. But after applying ResNet what provide that it provide us the very special amount of quality that we keep the features of previous layers into the last layer. Because what happens that when we proceed with multiple hidden layers, we getting loss of original features of image because of multiple time processing with multiple hidden layers. So to keep track of most precious features of image, we connect the residual connection. We skip the different layers and connect it directly with another layer so that we can maintain a record of important features of input images, so that we keep in mind or we keep remember all these features and produce good results. So that is why we need a ResNet, and due to ResNet, if we increase the number of hidden layers, we should definitely get lower training error. But if we do not use ResNet, then our training error will be increases. So why ResNet works? So I already explained you that why ResNet works, just because to reduce the computational or just to reduce the training error. And this is the architecture of ResNet. Thanks to MDNG and their team for this hard work. Because I already told you that I had taken all these slides and the materials, whatever I had gained understanding about convolution neural network is just because of Professor. I would like to thanks to their team for making such a great course. If you had enough amount of time, I would suggest you that please go through that videos if you have enough amount of time. And if you want a very intuitive level understanding, then you can stay here also. So I hope you are getting my point. And this is how ResNet works. I already explained you that you can see that we are doing skip connection. We skipping two layers. So like we skipping the convolution to convolution layer, and the connecting the first layer output from the third layer output, and do the sum and pass it into the relocation function. Again we say, so this cycle is going on similarly. Now networking networks and one into one convolutions. So earlier we had done the 2 by 2 or 3 by 3 convolutions, 3D shape or 2D shape convolution. But in this case, you will see that how the 1 by 1 convolution is happen. So in this case, the filter size is 1 comma 1. So this filter goes to every element of input size emit matrix and then calculate the, calculate the results and store into the another matrix. So one by one filter size and one is very important, but not so much. You will find definitely by the need of one by one filter. Using one by one convolution, we get 32 filters, 192 parameters. Oh, sorry, 192 number of, one second, what is here? 28 by 28 into 192. Basically, 192 is the number of filters used in processing. Now, coming to inception network motivation. What is inception network? So you can see that here is the image of 28 by 28 into 192. This image were processed by the one by one filter size, 3 by 3 filter size, 5 by 3, 5 by 5 filter size, and we applied also max pooling differently. All these outputs, we whatever outputs we are getting from all these layers, is simply adding them and getting the output size of 256. If we want 256 directly by one filter, then it is increase our computational cost. But if we do the partition of max pooling 5 by 5, 3 by 3, 1 by 1, then and then overlap their results, then it would give us a better understanding and better results. So you can see that how we get 256. Here in this case, you are getting 32 number of filters, and then yeah, you can see here 32 number of filters in 5 by 5 filter size convolution or same convolution. So for same convolution, we will definitely get 28 by 28 into 32. And in max pooling also we are doing same convolution. That is why we are getting 28 by 28 by 32. And in 3 by 3 filter size, we are getting 28 by 28 into 128. And 1 by 1 matrix size, we are getting 28 by 28 into 64. Not 64, I think. Yes, yes. It is 64 just because we are using 64 filters. So you simply can add 64 plus 28, 72, 82, 92, 92, 94, 104, 114, 124. So 124 plus 32, 126, 156 plus 256. So you are getting 256 number of filters and you are getting the output size of 28 by 28 by keeping same convolution. So this is how the inception networks will look like. You will see in detail. So here you can see 28 by 28 by 192 and 28 by 28 by 32. So convolution I used 5 by 5 same keep same in 32. Thanks for watching this video. See you again. Jai Hind.